Hello, this is video number 30 on my SQL variable calculus. In this video, we're going to talk about complex numbers. In high school algebra, you learned that some quadratic equations like x squared plus 1 do not have any real roots. So the roots of these equations are going to be what we call complex numbers. So the root of the equation x squared plus 1 is denoted by I. So I satisfies I squared plus 1 equals 0 or I squared equals -1. A complex number is any number of the form a plus bi, and I is square root of -1. A is called the real part of z, and b is called the imaginary part of z. And the notations are a equals re parentheses z close parentheses, and b is im open parentheses z close parentheses. Let's do a few examples on adding, subtracting, and multiplying complex numbers. The way we do that is by just combining the like terms and also considering the fact that I squared is -1. So let's look at these three examples. We want to add 1 plus 3i and 2 plus I. So the real parts add up to 3 and the imaginary parts add up to 2, and then there's an I for the imaginary part. For b, we want to subtract them, so we have to distribute the negative sign. We get -2 plus I. That gives us -1 plus 4i. So this is called the standard form of the complex number. A plus bi is called the standard form. For part c, we'll have to distribute, so we get 2 minus I plus 6i minus 3i squared. 2 and then minus I plus 6i is going to be plus 5i. I squared is -1 minus 3 times -1, that's plus 3. So that is 5 plus 5i. So that's the answer to this part. Okay, so now how do we divide two complex numbers? Let's remember how we divided by irrational numbers in high school algebra. So if let's say you wanted to divide 2 by 2 plus root 3, how did we rationalize the denominator? We multiplied by 2 minus root 3, and this 2 minus root 3 was called the conjugate. So the benefit of that was that we create difference of squares at the bottom, and then we can get rid of the square root. So we get 4 minus 3, so that gives us 4 minus 2 root 3. So if you want to divide a plus bi by c plus di, we multiply by the conjugate of the denominator, c minus di over c minus di. Now numerator is a simple multiplication. We could do that by distributive property, and in the denominator we could use difference of squares. So it's c squared minus di squared. Well, di squared is d squared times I squared, and I squared is -1, so that's -d, and there's a negative sign here as well, so we get c squared plus d squared at the bottom, and in the numerator we are multiplying a plus bi and c minus di, and that can be done by distributive property. Conjugate of a complex number z equals a plus bi is a minus bi, and the notation is z bar, so that is the conjugate. So let's look at an example on this one. Let z be 2 minus I over 1 plus I. We want to write down z in standard form. So we take 2 minus I divided by 1 plus I. We multiply by the conjugate, which is 1 minus I. At the bottom, we get 1 squared minus I squared, which is going to be 1 plus 1. On top, we will have to multiply 2 minus I by 1 minus I. We can distribute that. We get 2 minus 2I minus I plus I squared. Now the last term is I squared, which is -1, and then we have a 2 at the beginning, so we get 1 at the beginning, minus 3i, and then divided by 2. So the real part is 1/2, the imaginary part is -3/2. So the next part is, what is the real part? Well, the real part is 1/2, and the imaginary part is -3/2. So let's look at the third part. The third part is write z bar in standard form. So what is the conjugate of this complex number? It is 1/2 plus 3/2 I. So the answers are these values that we found. Let's look at the next topic. So we want to plot complex numbers on the complex plane. So the way we do that is very similar to plotting points on the xy plane. And the way we do that is the horizontal axis would consist of all real numbers, and the vertical axis consists of all numbers that the real parts are 0. So this point would be A, this point is bi, and z equals a plus bi would be the point whose real part is a and imaginary part is b. The absolute value of a real number is the distance of that real number to the origin. So we can define the absolute value of a complex number in a similar fashion. It is square root of a squared plus b squared, which is the distance of that complex number to the origin. So given that, let's do an example. We want to plot each of these complex number on the complex plane. The first one is z equals, we will distribute, we get 6 minus 2i plus 3i minus I squared. I squared is -1, there's a negative sign, so that gives us 7 and then plus I. So on the complex plane, we would have to look at 7 on the real line and I on the imaginary line, and this gives us the point Z. The next one, W, is we'll have to take the conjugate of 1 plus 3i, so that's 1 minus 3i divided by 1 minus I. Then we have to multiply by the conjugate of the denominator so that we can write it down in standard form so that we can plot it on the plane. So we get 1 minus I squared, and then in the numerator we get 1 plus I minus 3i minus 3i squared. Well, again, I squared is -1. -3 times -1 is 3 plus 1, that's 4. And then minus 2i divided by 1 plus 1. So this would be 2 minus I. So we have minus I, which is here, and then we have 2 that is here. So this gives us the point W. Let's look at one more example. Find the absolute value of each complex number. So for this complex number, the absolute value would be square root of a squared, which is 9, plus 16, and that is root 25, which is 5. So the absolute value is 5. For part B, we'll distribute, write it down in standard form, and then we take the absolute value. So we get 1 minus 2i plus I minus 2i squared. So again, I squared is -1, multiplied by -2, we get 2, and then we add 1, we get 3 minus I. So that means absolute value of W is square root of 9 plus 1, which is root 10. To summarize, what we did was we learned that every complex number can be written as a plus bi, and this is called the standard form of the complex number. In the standard form, a is called the real part, b is called the imaginary part. The conjugate of a complex number, z equals a plus bi, is z bar equals a minus bi. Every complex number can be plotted on the complex plane. The horizontal axis is the real axis and the vertical axis is the imaginary axis. The absolute value of a complex number, z equals a plus bi, is its distance to the origin, which is absolute value of z equals square root of a squared plus b squared. And that brings me to the end of this video. I will see you in the next video.